little bit about myself. I started building networks in the late 80s doing FTDI. Got hired by Cisco in 93. I was there till 2000. Started their security initiative in 96. For the last 10 years, I've been primarily consulting. Got roped into doing IPv6 in about 2003, 2004. I am an IPv6 Forum Fellow. I had written an IPv6 technology paper. If you Google that, it's still primarily relevant because unfortunately, as somebody else spoke earlier today, security is always an afterthought. With IPv6, it's also very unfortunately an afterthought, right? People are first trying to get packets from point A to point B and then go, oh, shoot, I don't want them going over there. So my talk is going to be based on a multitude of personal experience. I did a security assessment of the Comcast IPv6 rollout in 2006, 2007. Had some other large environments, connections by Boeing. I did their V6 architecture in 2004, 2005. Had the first /48 being routed by NTT, and that caused quite a controversy in the industry. So, you know, just basically these are all personal experiences from the last 10 years of actually deploying IPv6. So the topics for today, architectural design choices, basically security impacts. I'll give some pointers on how I would actually structure doing V6 today, and then where does IPsec fit in? So in terms of architectural choices, the addressing architecture is the fundamental piece that you cannot just spend a day on and say, I'm done. So I was really happy to see Owen's talk because I have been in too many environments where people go, oh yeah, the addressing plan. Okay, well, this is what we're going to do. We're done. And then a month later, they're going, oh, wait a minute. We screwed up. Now what? Right? And so I would very strongly encourage you to actually spend a week on it, you know, and get a bunch of people really looking at it to say, is this what we're going to do? Because you do not want to change your addressing later. As much as IPv6 was touted in the beginning as renumbering is easy, renumbering is always hard, things always break. Don't go there if you don't have to. The smallest globally routable prefix is a /48. Okay, don't forget that. So if you go after an allocation and you have multiple sites that you need to send some prefix to, remember that a /48 is in IPv6 the lowest that service providers will accept. It's equivalent to a /24 in IPv4 in terms of what's the smallest prefix routed in the routing table. Typically, subnets are based on a /64. I will contradict Owen, and apologies for that, but I would really strongly encourage people to use a /127 for point-to-point networks. There's issues, potential security issues with ping-ponging traffic back and forth. And what I've typically recommended people do is allocate a /64 for your point-to-point subnets, and then allocate /127s from within that /64. It also makes it easier when you're creating filters, right? And in terms of an addressing architecture, if you're creating /64s for whatever you're doing, allocate them consecutively so that you can actually create filters based on a larger you know, allocation so that it's consecutive. So you don't have to create separate filtering entities, because those are a pain. So that's about all I'm going to say about addressing. I think Owen did a great job for you know, discussing some architectural decisions. Just remember, you know, this is a fundamental, and it really helps with security issues, because remember that you're filtering based on addressing ranges, right? So it is important. In terms of evolution of IPv6 deployment, you could address devices since the mid-90s. I don't know how many of you use Cisco's or remember what a 2514 is. I have 3 of them at home, and I have the very last code that was shipped, 12.3. I use them as IPv6 test hosts because they do have IPv6 enabled. And I believe they stopped, you know, coding on those or, you know, shipping them in 2001, 2002. So IPv6 has been around in equipment for a very long time. Routing's been done, fixed. Most of the bugs were fixed in the mid-90s. Right, I think Sprint had an IPv6 core in 97, some others also. They fixed all the Juniper and Cisco, basically, you know, syntax bugs and all that. The biggest issues right now, or things that are still being worked on, evolved, enhanced. DNS is the one that, people always are wondering, well, what do I do with my quad A record returns or A returns? How quickly does that happen? So DNS is something you really need to pay attention to. And then also evolving enhancement, and specifically, this relates to security, is layer 2, 3 access controls, monitoring, and then also issues with applications. So transitions, I will also respectfully have a separate opinion from the previous speaker. I don't think there's a lot more to consider in terms of security with IPv6. Okay, you have the same kind of issues and concerns with IPv4. Usually, typically, you do only, change the addressing to IPv6. There's two major differences that you need to think about when you're looking at your security policy and looking at what features and functionalities you want. One of them is the fact that devices have multiple addresses. So rather than having a one global address, you have a global address, you have a link local address, and you might have some other ones that are associated with an interface. So rather than one, you can have 2, 3, possibly 4. So that's a concern. And then also the major point that you really need to think about when you're adding IPv6 into your infrastructures is the transition and coexisting technologies. Right? These are the ones that you have to see, how is this going to impact security? Who's going to have access to devices and applications that I don't want them to? So, initially, when the protocols were first created, IPv6 was first created, the transition technologies were the first 4 listed here, 624, Teredo, ISOTAP, NAT64. Recently in the IETF, and as people have become as they've deployed more and more, the more current choices are DS Lite, 6RD, carrier grade NAT, and NAT64, DNS64. So I would encourage people to actually read up a little bit on the last 4. Unfortunately, I don't have time in the session to actually describe them. Here's some pointers for IETF drafts. I'm sorry, these are the technical documents. For those of you that do configurations, I would encourage you to actually have a look at them. So some of the thoughts on transition is that, IPv-only connectivity does not exclude having a dual stack host that reaches IPv4 via an IPv4 and IPv6 tunnel. Yes, we are run out of IPv4 addresses, so you cannot get any more. However, that doesn't mean that your existing IPv4 doesn't work, right? So I'm sure that most cores are still going to be dual stacked. It's if you're adding new equipment and you don't necessarily have an IP address, what are you going to do with that? I worked in a cell phone provider, right? T-Mobile has had a IPv6 trial for over a year. A cell phone that's part of a T-Mobile trial will only have an IPv6 address. Okay, so there are going to be devices, usually end devices, that will only be IPv6. All right. So where does security fit in for IPv6 deployments? The fundamental issues are, what is meant by securing the network? I bet you if you ask 10 people in this room, you'll probably get 10 different answers. I mean, unfortunately, that's the industry, right? It means different things to different people. I've also heard too many people say, mimic what you do in v4, right? That's an absolute fallacy in my mind, right? Because in v4, you had a lack of addresses, which meant that you architected networks because, you had constraints with addressing. You may do things differently if addressing is not a constraint. You may not, okay? But at least leave for the possibility. So I always say, if you're looking at adding v6 into your environments, spend a day or two with your network architects and plan the network as if you would build it today and see whether or not you could do that with v6. And then look at what you have existing and see whether or not it matches or whether or not you can morph into what you want your networks to look like. Because otherwise you're just architecting into a legacy system which may not move into the future. In terms of security policy, it's a boring topic. People hate it. Risk analysis, boring. You have to do it. Because otherwise, how are you actually, what do you know what features to deploy? A lot of times the people that are configuring the firewall filters or implementing their IDSs, figuring out what to log. I mean, you become the people that create your company's security policies. Right? So you do have to really take a look at what are you trying to protect, why, and how likely is it that it's going to be an issue. Because the security policy will dictate which security measures to implement. So a couple of things with IPv6 security theory versus reality. I did get started in 2004 very heavily with helping the industry with IPv6 and understanding security architectures, because everybody at that time was talking about security being built in. And really what that referred to was that the IPv6 standards said that if you are IPv6 compliant, you must implement IPsec. Well, that doesn't mean you're going to turn it on. And quite realistically, a lot of the vendors in the early days did not implement IPsec, right? And so, we really have to look at what are the security enhancements, or how do you deal with security when you're adding IPv6. So end node addressing. There's a lot of automation built in with IPv6. A lot of that can also exist with IPv4, but it was added on later. So when IPv6 was created in the IETF, they thought, there were a couple of things that they really wanted to include. One of them, they wanted to learn from the mistakes and make it more secure if you can, but they also wanted to make it easier and provide more automation, right? Automation is not necessary, it's orthogonal to security, because security is more about having control over things. So neighbor discovery and router advertisement, I'm sure you've either heard about it or familiar, so because I don't have time, I'm not going to go over it in too much detail. But when a node comes up, right, it needs to address itself. So it creates its own interface identifier, which is 64 bits. It has to get the other 64 bits from the router to create its 128-bit global address. So a router typically sends out a router advertisement, every X times. If a node comes up, it doesn't necessarily have to wait for that. It can send a router solicitation message, and then the router should answer right away with the prefix, so then the node itself can create its unique address. Also, there's a thing called neighbor advertisement, and essentially that's creating your neighbor, I will call them ARP caches. It should be, neighbor discovery caches. And again, if I come up and hear another node on the link, I want to know who you are. I can send a neighbor solicitation, say, okay, who else is on the wire? Or if I come up, I'm also advertising myself, so my actual link local address. So in theory, in terms of security, you have a trusted router that sends a router advertisement, and you've got duplicate address detection built into the protocol. You've got secure neighbor discovery, which is SEND, or CGA, cryptographically generated addresses, privacy addressing and filtering. But in reality, you still have to think about really how do you avoid spoofing? How do you avoid denial of service attacks? And realistically, the host behaviors vary and need to be understood, right? What actually happens to a Mac, for a Juniper, for a 3Com, a mobile device, right? Because they unfortunately all have nuances, right? Standards just, give you less choices, right? But you really do have to understand the actual behavior. SEND and CGA are not widely used yet, but quite frankly, it's becoming more and more prevalent. It was interesting to me that the router vendors, Juniper and Cisco, both have SEND implementation. Microsoft doesn't have a shipping one yet. And in public, I haven't heard them announce anything, but I've always heard in back rooms that wait and see. So who knows when the announcement's going to be. But I personally expect SEND to be more widely deployed, and I would actually take a look at that. So in terms of addressing and addressing your nodes, right, you can use static addressing, where you actually define specifically the /128 that you're going to use. You can do stateful auto-configuration, which requires the use of a server. Stateless auto-configuration, which doesn't require anything else, like no manual configuration. And you also have privacy addresses. It's an RFC 4941. And what that does, it gives your node a unique address, you know, I don't know, every hour, whatever the time is settable. Or you can have router advertisements via DHCPv6. A combination of these is probably what you're going to use. If you're going to start out, right, all I would do, if you've never touched IPv6 before, it's time that you start. And all you really need is you need a laptop, you know, get a free sniffer, right? It's now called Wireshark, right? Download Wireshark. And if you have access to router, hopefully, you know, just enable IPv6. And then what I would do is run Wireshark and just start getting used to the addresses. It'll take you a week to understand IPv addresses if you've never, ever worked with them before. I don't care how smart you are, you know, because those hex numbers are interesting, you know, just to get your head around it. Statically defined addresses are typically used for critical devices, right? I mean, you really don't want to get around that. And one comment that I'll make here also with addressing is that with IPv4, if you've got a pretty good head for numbers, I remember the IP addresses pretty easily, right? And IPv6, no way. And nor do I always want to count on cheat sheets. You know, I don't type very well, so I make mistakes. DNS is your friend. DNS is going to be extremely important in v6 networks. And you have to make sure that you also are really familiar with DNS and make sure that it's as resilient as can be. And from a security perspective, I think more and more people are starting to understand how important DNS is. If I go into one more consulting environment and I ask them who their registrar is and they say, oh, we don't know, and they don't even know how many domains they own, right? Some people who own 500 or 1,000 domains, I usually want to know the entire list, right? Because you don't want to get into a DNS domain hijacking. But DNS is going to be extremely important with IPv6 and addressing. Privacy addresses are used by default by Vista. I'm not against them, but I really care about auditing logs, right? If something bad happens, I want to go to the source. So if the source's IP addresses changes all the time, do I have the information somewhere so I can see which IP address correlates to which MAC address at a certain time? So just keep that in mind. I'm not going to go through this in detail. You're going to have these slides later, right? I don't have this much time, unfortunately. Some people ran over. But there's work that's being done in the industry, and primarily I list them as equipment vendors who have software bugs, right? There's memory allocation issues sometimes if somebody is sending too many neighbor discovery advertisements, right? Caches can't keep up, you know, devices die. So as far as I'm concerned, right, these are all issues that really shouldn't have happened. I don't think they're new security issues. These are software bugs as far as I'm concerned. You know, being able to rate limit, this is not a new concept. So these are, I've basically summarized in these slides a bunch of issues that have been discussed in various mailing lists and things that vendors are actually working on. So if you take a look at these slides later, you're looking at devices that you want to use in an IPv6 environment, you have to know to ask the right questions and to see whether or not a vendor has had issues with any of these. Securing the device, right? It's the same as v4 and v6. I have a pretty nice sandbox at home. I actually have EBGP. I have a full v6 routing table to my home router. I just checked, it's up to 7,373 routes for IPv6. And I will say that as of v6 day in June, the routing table, the global IPv6 routing table has grown by at least a couple of hundred routes per month. You know, I think last time I looked, it was up to 5,000. That was maybe a month and a half ago, 2 months ago. So people are paying attention. Device access, right? You want to control who has access to the console port, aux port, virtual VTY ports, any way that you can get access. I have gone into large environments who are starting to play with IPv6. They say IPv6 enable on their Cisco routers. I look at the config and I'm like, do you realize that on your VTY ports, you know, if people knew your prefix and if they, you know, knew maybe an address, they could access this router? Right? And they're like, oh yeah, I forgot. Right? Security is an afterthought. So even if you're doing a trial, right? Don't just turn on IPv6 and go, oh, let's just see what packets are going where, unless you don't care if somebody has access to that device. You know, and over the years, I've really learned that even if I'm testing something, I don't want to use a password like Juniper, Cisco, test, or whatever, because whatever you do in practice, right, even in testing, you're going to do somewhere more important. And so it's always good practice to, even when you're testing things, use a password that nobody will understand, you know, even if it's 5 characters. On my iPhone or Android phone, just for the heck of it, I downloaded an app. And this application had 3,000 very common devices and their default passwords in them. And there's also applications where it says, you know, here's the most common, you know, 2,000 passwords that people use. It's easy to break into boxes, right? So, you know, in this day and age, I mean, just use, I don't know, make up something funky and, you know, put an ampersand and put a 684 in it, whatever, right? At least it's not going to be easy to guess. Because there's scripts out there, tons of them. So anyway, access control best practice, same as v4 and v6. Management plane filters, don't forget about them, right? If you can have access via v4, if you've enabled v6, right, make sure that you have filters for also all of your management devices. Use SSH. I don't ever want to see Telnet anywhere. v6, all devices that I've ever touched, at least, you know, within the last 6 months, if it works for v4, it works for v6. All right. So here's just a synopsis of device management. Really, seriously, it's the same with v4 and v6, if you're going to be running it in a dual stack infrastructure. And this is what I mean by that. Device management considerations, right? With the evolution of adding v6 into your environments, most of your management infrastructure and provisioning is done over v4. Not all of the devices had supported v6. And since most of the devices were dual stack that needed to be managed, right, why add v6 to it? So it's quite okay to use only v4 transport to manage today. But you really do want to get your vendors to have v6 on their roadmap. Okay, you have to understand when they will have the capabilities so that throughout your entire management infrastructure, you don't all of a sudden have a gaping hole and, oops, that didn't support v6. Okay, I think in the last year, the vendors have gotten much better and they're shipping much more products and much more features and functionality. But the management piece has definitely been sorely missing, right? syslog, right, NTP, what is available over v6 infrastructure? Don't make assumptions, right? And I think that's the main thing that I want, a takeaway, is that you do not want to make assumptions with v6, right? You want to ask the even, fundamental questions, because sometimes you might be surprised at vendor answers. Securing the data. This is the same with v4 and v6, right? It primarily comes down to filtering and rate limiting. So these are just, regular questions, that you have to consider with considerations when you're creating filters, recommendations. And these are the slides that I think are important for v6. I actually spent quite a few days, I was going to say hours, but it was actually days, consolidating a couple of RFCs that were written, as well as industry best practices from people that have been deploying v6 for about 10 years. Most of the filtering recommendations are extremely similar. There's some differences, okay? They're pretty minor, but you will have to understand them. So these are recommendations, and these are basically prefixes that have special meaning that you want to think about filtering. And I will also say that I worked in an environment, and I won't name them, but I was extremely impressed by some of the engineers, because there are a number of these special prefixes that people usually create separate filter lines for them. the engineers in-house were clever enough to turn 10 lines into 3. Right, and I will leave that as an exercise to the reader, which I hated in college when the professor said that. However, I don't want to give their work away. So I've just listed the very common prefixes that you do need to think about. And the very last statement here is important, which is care must be taken not to reject IC and IPv6 packets whose source address used with duplicate address detection is the unspecified address, which is the ::/1 at 28. If all of IC and IPv6 is accepted, then there is no problem, although ordering of the filters needs to be carefully thought through. So these are nuances, right? These are nuances that you find when you're actually testing and deploying. So I'm giving you some cheat sheets here. In terms of IC and IPv6, right, with IPv4, people panicked, I don't know, what was it, 12 years ago, 13 years ago? I think it was the land sea attack, right, which basically, it was an amplification attack with ICMP. So people panicked and turned it all off, right? You cannot do that with IC and IPv6 because you need specific types for neighbor discovery and router advertisements, packets too big, PMTU discovery to work. So personally, right, I don't recommend filtering IC and IPv6 because the fat fingering that occurs is too much of a pain. If you're in a smaller environment, yeah, go for it. If you're in a really large environment and a configuration mistake can cause you literally millions of dollars, may not be that important. Okay, so here's a list actually of the IC and IPv6 messages that should be allowed through the firewall or to and from a firewall. And these are taken specifically from best current practices and requests for comments. One thing, I have a litmus test question to see how well a vendor understands IPv6, and I say, how do you deal with extension headers? When I get a blank stare, I say, okay, now show me your roadmap. Right, and from security, okay, this has come up in the past couple of years. Security vendors have gotten a lot better, but I was looking at one tester device, and they were great with v4. Love them for v4. They have IPv6 capability, so I asked them how do they deal with header extensions. They had no answer. And what they ended up doing was, the 50,000, automated attacks that they look for, all they did was, instead of a v4 header, they slapped a v6 header on. And I'm like, okay, that's nice. So what happens if somebody crafts, an extension header that has something weird formatted, right? What's the device going to do? So from a security perspective, right, and in terms of testing and what's out in the wild, you want to monitor. Monitor is critical. And in my home router, I'm doing a test, okay? Because in the industry, people are wondering, should a CPE firewall be on or off, right? Should you do more host-based firewalls and all that? I'm of the mindset that we have to be much more cognizant at the host level. And I have made a decision to do no filtering for IPv6 on my IPv6 router. Because should something happen to my home network, it'll take a day to just, rebuild everything. Okay, I can take a day. What I want to see is when somebody is going to send me a packet that I don't want. So I look at my logs, right? And I've done this for the last 6 months now. I haven't seen any unwanted IPv6 packet. However, and it's a big however, right? Not enough people are using IPv6 yet, so I'm not going to make that statement to say, you don't need a firewall, I haven't seen anything, okay? Give me 2 more years, okay? In 2 more years, I might make that statement. So, but I will very strongly encourage you that if you are testing IPv6 and you're starting to send IPv6 traffic, and I strongly encourage you to do so. I don't want to say you're late, but you're late. Okay, if you haven't touched it yet, right? I mean, start testing IPv6 in whatever environment you can, but definitely log and know what's on your network, know what's on your wire. So these are the references for the best current practices that exist out there for filtering, Again, the slides before that is basically I took all of them, and those are the recommendations that I usually give. IPsec and V6 architectures, I'm not going to talk about it too much. Let's just say that IPsec is not as widely used as it could be. I blame the vendors a lot for that. I think the terminology they use is atrocious, right? They use different things to mean the same thing. So for example, SA, phase 1, and main mode all mean the same thing, right? Different vendors decide to use different terminology. It's all taken from the RFCs, so they're not quite wrong. But as somebody, as a user or an operator, it gets really confusing. And most of the mistakes today aren't interoperability mistakes, they're user error. But vendors should be better about making the configurations easier. Just about all IPsec implementations do support IPv6. That's been true actually for the last 2 years already. And I guess it's like 3 years ago now. There's one common myth that I want people to understand. And I guess I don't have a slide on that. I get very disencouraged when people say, well, if I use IPsec, I can't use my IDS devices or stateful firewalls. And that is absolutely incorrect. IPsec does not equal encryption. Okay, it does. You can encrypt traffic if you want to, but IPsec, in my mind, should always be used for integrity protection. Okay, I will argue that to the end. So it used to be that IPsec had two components, AH and ESP, right? AH authentication header, which provided integrity protection for the entire packet, including the IP headers. And ESP was then the encryption add-on. And that's because in 1998, when IPsec became a standard, you had all of these issues with shipping encryption, right, with big keys, longer keys. So in the US, you couldn't export encryption products that had longer than 40 keys, but for authentication and integrity, it didn't matter how long the keys were. Right? So it's a historical artifact. In reality, what most people do is they use ESP. And it turned out that with AH, I was actually at the interoperability, IPsec interoperability event in '98, where they discovered that, oh, AH, it doesn't go through NAT devices. Bummer, right? So they created something called ESP null. And some people thought it was an April Fool's RFC. It's not. It's deployed. People are using it. And what that means is you're using ESP, but with null encryption. So you're still using the integrity portion of it. The difference between AH and ESP is that the header, so the IP header, either IPv6 or IPv4, is not integrity protected. And if you understand IPsec well enough, most people don't get this nuance. But because you are actually, you have this security, what is it, database, whatever. I can't remember now what it's called. But it's the database of connections, right? If you're sending me an IPsec protected packet, right, I look in this database and say, does the destination IP address match, right? Do we have the security association? So inherently, I'm already protecting the IP address. Right? If you're spoofing the destination IP address, we don't have a security association, I drop the packet. So, you really have to think really in detail, through these things. So anyway, so ESP null, right? You can still integrity protect your packets from sender to recipient, have some modicum of security, right? Integrity is huge. At least you can validate that, the packet came from who you think sent it. Right? And so, and your firewalls, your IDSs will still have no problem. There's one nuance, and that is within the ESP protocol, it wasn't very easy to detect whether or not you're using ESP null or not. So are you encrypting the packet or not? And I dropped a slide that actually shows the picture because I didn't think I'd have enough time to show it or go through it in detail. But it's, you have to go through the entire packet. At the end of the packet, there's this ESP trailer, and from there you could tell whether or not the packet's encrypted or not. right? The problem is that in most devices, right, they only look through the first X bytes, right, so that they can quickly forward the packet. So these are things that have been recognized in the IETF. People have worked on standards to actually solve them, but these are questions that you want to ask your vendors, right? So if you're at all interested in integrity protection, you want to use IPsec, the question that I would ask, so with ESP null or ESP, you know, how do you implement, how do you detect whether or not it's encrypted or not? So, okay, and so this here, if you're interested in IPsec, there's, you know, a bunch of templates. These are the best tutorials that I've found if you just want some cheat sheets. Actually, the best one is VPNC.org. So www.vpnc.org, VPN Consortium. They have somewhere on the top, it says like profiles, and what Paul Hoffman, who runs a consortium, did 10 years ago already, and I created one of the profiles like 8 years ago, is because of all the issues with interoperability between different vendors, there's probably about 100 or 200 configurations from different products. Even like Cisco, right, who has like 50 different products, they've got 50 different configurations in there for the same scenario. So you have a scenario that uses passwords, shared secrets, one that uses certificates, and you have examples in there. So to me, that's the best cheat sheet if you want to, you know, do something with IPsec. So as a summary, and I'm sorry that I moved so much into the break, do not break the existing IPv4 network. That was always, when somebody asked me to come in and look at their v6 and architect stuff, they said, do not break our v4. Some of them said, our v4, don't even comment on it, it's legacy, we know it's bad, you know, don't break it. How do we deal with v6? Securing IPv6, addressing infrastructure needs careful thought. I cannot stress that enough. That is the fundamentals of everything. You do not want to get that wrong. It's not a day's work. It might not even be a week. You might want to spend a month on that, okay? You want to get it right the first time. Go native where possible to avoid tunnels being used, okay? Tunneling, malicious behavior, if it's tunneled, it's very hard to detect. Go native if possible. I will always stress go native. Do the hard work up front. You'll be happy later. And use simple initial controls when getting started with IPv6, right? Don't forget about your VTY access lists, right? Have only those people that need access to the devices only have access to the devices using IPv6. And also, don't just blindly mimic the IPv4 security architecture. Think carefully about NAT. Okay, I will end with saying that I am not a strong believer of network address translation, right? Because it makes auditing and logging and, you know, trying to figure out who the miscreant is and where the source of malicious behavior came extremely difficult. Make up your own minds. It's your environment. I don't have to deal with it. But if I have to deal in an environment, I very strongly encourage people not to use NAT. That doesn't mean you don't want stateful firewalls. Okay, and you have to understand there's a difference. Typically, stateful firewalls include network address translation, so people think NAT equates to stateful firewalls. That's not true. So, and I will end it on that. I will take